This video is about understanding and using the true statement that corresponding parts of congruent figures are congruent. So remember, when we're talking about congruent figures, we're talking about figures that have the same size and shape. When we're talking about congruent sides or angles, we are talking about that they have the same measure. So first, let's talk about how to identify corresponding parts of figures, especially if there's been some reflections or rotations taking place. Sometimes it can be difficult to tell which parts are corresponding. Well, the trick in that is in looking at the order of the lettering when they name the figures. So here it says triangle ABC is congruent to triangle DEF. And so notice the order, because the order is important. A and D are the first letters in the name of these two triangles. That means point A, or angle A, corresponds to point D, or angle D. In the same way, B and E are both the second letters, so angle B corresponds to angle E. And C and F are the third letters, so angle C corresponds to angle F. We can also do that with the sides. AB are the first two letters, and DE are the first two letters. So side AB of this triangle corresponds to side DE of this triangle, and so on and so forth. So, corresponding parts of congruent figures are congruent. That means that corresponding sides all have the same measure, and corresponding angles all have the same measure. For example, angle D here measures 73 degrees, and its corresponding partner on the other triangle is angle A. So we know angle A also measures 73 degrees, and that's because we've already been told that these two triangles are congruent to each other. In the same way, I see that side BC is 3.7 centimeters long, and BC corresponds to EF. So I know that side EF must also be 3.7 centimeters long. So understanding that concept, we can go ahead and answer these questions. It says triangle ABC is congruent to triangle DEF. Find the given side length or angle measure. So number one says we need to find the length of side DE, which is right here. So I look back at the names. DE are the first two letters. So that means side DE corresponds to side AB. And we see here that side AB measures 2.6 centimeters. So now I know that side DE also measures 2.6 centimeters. And number two says find the measure of angle B. So angle B is right here, and we see angle B is the second letter, and E is the second letter. So if I look over at angle E, it measures 65 degrees. So I know that the measure of angle B is also 65 degrees. So now let's talk about the properties of congruence. And these are similar to the properties of equality. So we have the reflexive property of congruence, which says side AB is congruent to itself. And that's what the reflexive property is saying something equals itself. Okay. Then we have the symmetric property of congruence, which means that we could change the order. So if side AB is congruent to side CD, then we flip that around. Side CD is also congruent to side AB. And then we have the transitive property of congruence. Remember, we talked about transitive is like transfer. It's the transferring equality, right? So if side AB is congruent to side CD and side CD is congruent to side EF, then that means that side AB is also congruent to side EF. So we could use congruence and corresponding parts to answer these questions. So it says here, triangle ABC is congruent to triangle DEF. Find the given side length or angle measure. So we see here that for number one, they want us to find the measure of side AB. So in order to do that, we need to figure out who's the corresponding partner. So AB is the first two letters and DE are the first two letters. So side AB corresponds to side DE. That means that they are equal to each other. So I could use that to write my equation. So my equation is going to be an equation with variables on both sides. So side AB, which is 3x plus 8, is equal to side DE, which is 5x. So let's solve. So first I need to eliminate one of these variables. So I'm going to subtract 3x from both sides. And I get here 2x equals 8. And then when I divide by 2, I get x equals 4. But that's not enough because that's not the measure of this side. Now I need to plug that into here. So 3x plus 8, right? So if x is 4, this becomes 3 times 4 plus 8. 3 times 4 is 12. And 12 plus 8 is 20. So the measure of side AB is 20 inches. Looking at number 2, we need to find the measure of angle D, which we see is right here, and we know that angle D corresponds to angle A. So again, angle D says 6y plus 2, and angle A says 5y plus 11. So we could set up another equation. So I have here 6y plus 2 equals 5y plus 11. And so again, I need to solve this. So I'm going to subtract variables. So I'm going to subtract 5y from both sides, leaving me with y plus 2 equals 11. And then when I subtract 2 from both sides, I get y equals 9. So now if y equals 9, I want to find the measure of angle D. I need to plug that in here. So I have 6 times 9 plus 2. 6 times 9 is 54. And 54 plus 2 is 56. So the measure of angle D is 56 degrees. So next, let's talk about using congruent corresponding parts in a proof. Now, proofs are a major part of geometry. So a proof is giving evidence that a statement that you are making is true. You can't just say something is because it looks like it. You need to give mathematical, geometrical evidence that it is true. So for example, this golden figure here looks like a rectangle. But in geometry, I can't just name a figure a rectangle because it looks like it. I need to have proof. So if I know that this figure has 4 right angles and that opposite sides are congruent, now I have proof that this is a rectangle, and I can say, hey, this is a rectangle. So let's take a look at this first example here. It says, given triangle ABD is congruent to triangle ACD, prove that D is the midpoint of line segment BC. So when we start, we give our statements and our reasons, and our first statement is always the given. So triangle ABD is congruent to triangle ACD. And what is our reason for that? Because it's given. That information was given to us. So how can we use this to prove that D is the midpoint of line segment BC? Well, we have to go back and think about what we know about midpoints. We know that midpoints bisect a line segment, which means they cut them perfectly in half, which means that BD and DC are congruent. They have the same measure. The question is, can we prove that BD and DC are congruent? And the answer is yes, because we know that triangle ABD is congruent to triangle ACD. And if these two triangles are congruent to each other, then their corresponding parts are also congruent. And we know that BD and CD are corresponding parts. So our second statement is that line segment BD is congruent to line segment CD. And the reason is because corresponding parts of congruent figures are congruent. And that is enough to prove that D is the midpoint, because if BD is equal to DC, then D cuts BC perfectly in half. And so that is our third point. D is the midpoint of BC. And what is our reason? Well, that is simply the definition of midpoint. So we have successfully proven that D is the midpoint of line segment BC. So let's take a look at our next example. It says given quadrilateral JKLM is congruent to quadrilateral NPQR and that angle J is congruent to angle K, prove that angle J is congruent to angle P. So again, our first statement is going to be that quadrilateral JKLM is congruent to quadrilateral NPQR. And the reason for that is it's given. We have a second given statement that we can put in there, and that is that angle J is congruent to angle K. And that is also given. So what else do I know here that could help me? Well, I know that angle K corresponds with angle P because K is the second letter here and P is the second letter here. And if they correspond, then they're also congruent. So my third statement can be that angle K is congruent to angle P. And the reason is because corresponding parts of congruent figures are congruent. Now that I've proven that angle K is congruent to angle P, I can prove that angle J is congruent to angle P because if angle J is congruent to angle K and angle K is congruent to angle P, then angle J is also congruent to angle P. And the reason for that is the transitive property of congruence. All right, so one last example here. It says, given triangle SVD is congruent to triangle SWT, prove that line segment ST bisects angle VSW. So I see here that here is my triangle SVT right here, and here's my triangle SWT, and here's angle VSW, and here's line segment ST. And so we want to prove that this line segment here, ST, bisects VSW perfectly in half. So where do we begin? We begin with our given statement. So our given statement is triangle SVT is congruent to triangle SWT, and the reason for that is it is given. So in order to prove that line segment ST is a bisector of angle VSW, we need to prove that angle VST and angle WST are congruent, because if ST is a bisector, then it cuts the angle perfectly in half, which means both halves are exactly the same. They're congruent. They have the same measure. And so we do know that angle VST is congruent to angle WST. And the reason for that is that corresponding parts of congruent figures are congruent. And so VST is an angle from the first triangle that corresponds to WST from the second triangle. And knowing that, we can now prove that line segment ST bisects angle VSW. And the reason for that is because that is the definition of an angle bisector. All right, so now you should understand and be able to apply the concept that corresponding parts of congruent figures are congruent.